Okay, so 7.1 is interior and exterior angles. And we're going to learn some more about the interior and exterior angles of a triangle and other polygons. So for this little activity, we're going to sketch every diagonal starting from the indicated vertex to the other vertices. So see, here's the indicated vertex, and we go to each of the other vertices. Okay, so on this first triangle, it's all done, isn't it? I mean, the sides are all to the vertices. And this one, all we have to do is make this one. Here, I'm going to go from here and to there. Here I go down. And then on this one, whoops, that's a little bad, but I guess it's all right. And then let's see, I go from here and those are all done. And then we got all those. And then all these. Okay, now, what I want you to notice is at the bottom, N stands for the number of sides, okay? So I want you to fill out this number of triangles. So if there's 3 sides, I see 1 triangle. If there's 4 sides, I see 2 triangles, okay? If there are 5 sides, I see 3. So go ahead and fill that out for me. And you should end up with all these. And you ought to notice that the number of triangles follows the pattern of 2 less than the number of sides. So out here, if there's n number of sides, I have n minus 2 triangles. Now, how many degrees are in a rectangle? Well, we all know that's 180. So when we talk about the square, we see 2 triangles. So all those angles have to add up to be 360. And if there's 4 triangles, they should add up to be 720. And 5 triangles would be 900. And then 1080. And then what? 1160. And then 8 triangles would be 8 triangles would be 1440. And then 9 triangles, 180 would be 2, 4, 5, 1620. And then triangles, 10 triangles would be 1800. So this pattern follows 180 times the number of triangles. And that's what these questions are. Compare the number of triangles. Well, there's 2 less. How does the number of triangles created by the diagonals in each polygon determine the sum? So the sum of the interior angle measures in a polygon follow this formula. 180 times n minus 2, the number of triangles inside it. All right, and so here we go. The sum of the measures of n interior angles of an n-gon is 180 times n minus 2. The polygon angle sum theorem is what it's called, and there you have it. 180 times n minus 2. And remember that n minus 2 is the number of triangles, and hopefully everybody knows that there's 180 degrees in each triangle. So in a regular hexagon, how could you use the sum of the interior angles to determine the measure of each interior angle? Well, first off, let's talk about the word regular. If it says regular, all angles are congruent and all sides are congruent. Okay, so how do you use the sum? Well, let's find the sum. So regular hexagon. Okay, sorry. The janitor came in and was sweeping. Okay, so in a regular hexagon, how would you use the sum of the interior angles to determine the measure of each interior angle? Well, first, let's find the sum of the interior angles. So a hexagon has 6 sides. So I'm going to say 180 times 6 minus 2. And I got 720. Okay, so all the angles add up to be 720 degrees. How many angles did I say there were? That's right, 6. So if I divide that by 6, I get 120 degrees each. How do you determine the number of sides of a polygon whose interior angle sum is 3,240 degrees? Well, let's think again about this formula. So we have the interior angle sum equals 180 times n minus 2. Okay, so the interior angle sum is what they gave us, 3,240, and then 180, n minus 2. So I'm going to divide each side by 180. And get me 18 equals n minus 2. I'm going to add 2 to both sides, and I get 20 equals n. So 20, it has 20 sides. Okay? Then you just work backwards. All right, so determine the unknown angle measures. Well, let's see how many sides there are. 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So all of my sides, oh, hang on. All right, so there's 9 sides. So 180, 9 minus 2 gives me 180 times 7. And 180 times 7 is 1260, right? So now we have to add up all of those. So 135, or we just do, so 135 plus 98 plus 102 plus 140 plus 200 plus 172 plus 130 plus 125. So if I add up all of these, I get, oops, not plus. I get 1102, so I'm going to subtract that from that 1260. And I get 158. So this last angle will be 158. So now it says, determine the unknown interior angle measure of a convex octagon in which the measure of the 7 other angles is 940. Well, the interior angle sum of an octagon, right? We have to find that. So 180 times 8 minus 2, because the octagon has 8 sides, gives me, let's see, 180 times 6 is 1080. So I'm going to subtract that 940. And I get 140 degrees would be the unknown angle measure. Now this next piece, we've already talked about a lot. All the angles in a triangle add up to be 180 degrees. So consider the triangle sum theorem in relation to a right triangle. What conjecture can you make about the 2 acute angles of a right triangle? Well, the 2 acute angles of a right triangle need to be equal to 90 degrees, don't they? They would be complementary. Let me write it. The 2 acute angles in a right triangle are complementary. Okay, so next. Determine the unknown angle measure in this pentagon. Okay, so first off, let's see what they're all supposed to add up to be. So I have I'm going to actually write out interior angle sum equals 180 times n minus 2. And I have 1, 2, 3, 4, 5 sides. So 180 times 3 is 540. Okay. Now I'm going to take 540 and I'm going to subtract 90, 90, and 90. So what is that, 270? And I'll write that out here, 90 times 3. And I get 270. And then 270 divided by 2 is 135. So each one of these x's has to be 135. Determine the measure of the 4th interior angle of a quadrilateral if you know the other 3 measures are those 3. So a quadrilateral has 4 sides. Now we should probably know that a quadrilateral, all the angles add up to be 360. Okay, and then I'm going to subtract the 89, the 80, and the 104. So when I do that, I get, what, 87. Again, a hexagon has 6 sides, 1, 2, 3, 4, 5, 6. And we're going to find out how much they all add up to be. So 180 times 4 is 720. And then we take that 720 and we subtract. Well, let me write it as a equation. So 69 plus 108 plus 135 plus 204 plus B plus 2B has to equal 720. So I'm going to get, all that adds up to be, I'll just go ahead, 3B, right? 1B and 2B, 3B, and then all these add up to be 516. And then I subtract 516 from both sides. And I get 3B equals 204. And divide by 3, and I get 68. Let's see, what's going here? So now we have an exterior angle is an angle formed by one side of the polygon and an extension of the adjacent side. Exterior angles form a linear pair with the interior angles. Okay, so look at this picture. Here's an exterior angle, and here's an interior angle. See how they form a linear pair? That's what that statement is talking about. A remote interior angle is an interior angle that is not adjacent to the exterior angle. So here's an exterior angle. Here's the remote to interior. See, this interior angle would be right against it. Remote means far away. Okay? So let's talk about the exterior angle theorem. But first let's write something down here. We know that angle 3 plus angle 2 plus angle 1 equals 180 degrees, right? We also know, hang on, let me write this in pink. Angle 2 plus angle 1. So we also know, because those are all the angles in a triangle, right? 1, 2, and 3. So now, we know that 3 and 4 make a linear pair, right? So angle 3 plus angle 4 also has to equal 180 degrees, okay? This is angles in a triangle. Whoops. Angles in a triangle, and this is a linear pair. Now, when we look at this, what do you notice here? You notice that angle 2 and plus angle 1 has to equal angle 4. Do you see that? Angle 2 plus angle 1 has to equal angle 4. So that is what the remote interior angle theorem says. Okay? The two remote interior angles equals the exterior angle. Let's look here. And here we go. The measure of an exterior angle is equal to the sum of the measures of the remote interior angles. Okay? So determine the measure of each exterior angle, then add them together. Okay, so let's do that. First off, right here, 60 plus 40 is 100. So this angle should be 80, correct? And then this one is 120. This one is 100. and this one would be 140. They all make linear pairs. Add them together. So 100 plus 140 plus 120 equals 360 degrees. Okay? All exterior angles, no matter what shape, add up some, to 360 degrees, okay? Octagon, triangle, you name it, whatever it happens to be, okay? All the exterior angles add up to be 360 degrees. Okay, so exterior angle equals the sum of the remote two interior angles. So at 147 equals 7z, so 21 equals z. Here, 3x minus 8 equals 90 plus x plus 2. So 3x minus 8 equals x plus 92. Move the x over. Add 8 to both sides. And divide by 2. All right, stop this video and see if you can do the next two on your own, and then come back and check. Okay, so somehow I made this little mark here. All right, so that you should have gotten x equals 10 and x equals 50. And I haven't talked about these problems. If you need help with them, then you should come in and see me on Wednesday, or ask me Wednesday in class, okay? So next that's it, the homework. So holler at me if you've got any issues.